Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Killer Knight Sudoku, which is by Vizumation. And here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. Digits in cages cannot repeat and must sum to the small clue in that cage. And these are called killer cages. So that's why it's a Killer Knight Sudoku, because we have killer cages in here. So, for example, these three digits must add up to 9. These three must add up to 21. So, as an example, this could be 5, 7, and 9, because those three digits add up to 21. What could not work, though, would be something along the lines of 9, 3, and 9. Because though they add up to 21, you have a repeat in this cage, and that's not allowed by normal killer cage rules. There are variants. Actually, I think I did one either yesterday or the day before, which basically required repeats in the cages. But this one does not. This one actually is normal killer cage Sudoku rules, which is you cannot have repeats in cages. So again, this 399 does not work because of that. Because you cannot have repeats. Remember that in cages. Digits in cells with a gray square must be even. So these are obviously 2, 4, 6, or 8 because they're even. And cells separated by a knight's move cannot contain the same digit. So, for example, in addition to other restrictions, which is normal Sudoku restrictions, where you can't have repeats in the same row, column, and box. In addition, say we had this cell. Anything that's a knight's move away also cannot have repeats. So none of these cells can contain what's in this green cell. So say this was a 9, none of these red cells could also contain a 9, in addition to the rows, the columns not containing a 9, and the box not containing a 9. And that's knight's move rule set. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, the first thing that pops to my mind, seeing this, is the 24 cages and the 6 cages. The 24 cages, there's only one set of 3 unique digits which can ever add up to 24. And that's 7, 8, and 9. Similarly, for the 6 cage, there's only one unique set of 3 unique digits, which can add up to 6, which would be 1, 2, and 3. The remaining digits now in box 5 have to be 4, 5, and 6. So this is 4, 5, or 6, this is 4, 5, or 6, and this is 4, 5, or 6. If this is 4, this could be 8 and 9. If this is 5, this would have to be 7 and 9. And if it's 6, it has to be 7 and 8 to add up to 21. Okay. This digit has to be then the same as this digit, because it sees this one from normal Sudoku and it sees this from knight's move. So we are going to mark that here. Those are the same. Similarly, this digit cannot be either of these two. This one from normal Sudoku and this one from knight's move. So it must be the same as that one. So we're going to mark that here. Okay, what else do we know? This, what are the possibilities that can add up to 11 for 3 digits here? 1, 2, 8 is not allowed anymore because of the 7, 8, 9 triplet in the box. 1, 3, 7 is not allowed, so this could be 1, 4, 6. It could be 1, 2, 3, 6. And I think those are the only possibilities, right? Again, no 1, 2, 8, no 1, 3, 7. Then you have 1, 4, 6 is possible. That's all the ones as the lowest number. You could have 2, 4, 5. 2, 4, 5 also works. So if this is 1, 4, 6, this has to be 2, because that's the only even digit remaining. There's always going to be 2 even digits in this set of 3, and we know 8's already taken. So because of that, if this is 1, 4, 6, this has to be 2. If this is 2, 3, 6, this is 4. If this is 2, 4, 5, this is 6. Not 5, this is 6. So the remaining digits here cannot be the even digits because all 3 of them have to be taken care of by this cage and this even digit. So it could be 1, 3, or 5 in the corners. Okay. Interesting. Here the digits are all 1 through 6. Here the digits are all 1 through 6 because the largest digit you can ever have, adding up to 9, is 6 with 1 and 2, right? Because that's the minimum values with 1 and 2 you could have. So you could have as maximum a 6 with it. Therefore, in the column 8, we have a 1, 2, 3, 4, 5, 6 sextuplet, which all must contain 1 through 6. So the rest of the column cannot contain 1 through 6. So it has to be 7, 8, or 9 here. Okay. What else do we have here? Hmm. I'm not sure we have anything else. This could be 1 through 7, because again, if you take the 2 lowest digits and you add the highest digit possible, it would be 1, 2 subtracted from 10, which would be 7. But that doesn't really tell us much. Oh! We do know... Well, no, we don't. Never mind. Actually, we do know one thing. Okay. Where is this central cell in box 6? Can't be the orange. Actually, just can't be any of these. Because it's... because of normal Sudoku and Knight's Move from these two. Can't be any of these because they cannot be from 7 through 9. So it has to be one of these 3. Can't be here because of obviously this is pink and that sees it from normal Sudoku. So the pink in box 6 has to be one of these 2 cells. Well, that eliminates them from being pink in these 2 cells. So where is the pink in box 3? It has to be this one. So this is pink in box 3. That means in box 9, pink has to be one of these 2 cells. So, where's the orange in box 3? It has to be one of those 2. And similarly, the blue has to be one of those 2 also. This has to be orange or blue. And this is orange or blue. Ah, well, where's the pink in box 2 then? Can't be any of these cells. Can't be any of these cells from normal Sudoku and Knight's Move. Can't be here from normal Sudoku, so it must be in this cage. Well, the only possibility to be in that cage would specifically be a 7. Therefore, we know the pink has to be a 7. So this is 7, this is 7. The pink has to be one of these 2 cells. So it's 7 with 1 or 2. So this is 7, 1 or 2. This can't be 7. This obviously can't be 7. None of these could be 7. So this has to be 8 and 9 here, adding up to 17, which forces this to be a 4. So this is 4 then. None of these could be 4. These can't be 7. This can't be 7. This cannot be 1 and 2 because of the 1, 2, 7 triplet here. Therefore, none of these can be 7 because if we had to have a 7 here, then this would have to be 1 or 2 or 7, but that's eliminated by the 1, 2, 7 triplet in the row. So this has to be at most 6. This can't be 1 or 2 because of the 1, 2, 7 triplet here. Yeah, so then what can this be? It could be 1, 4, 6, that's possible. It could be 2, 3, 6, or 2, 4, 5. So this has to be specifically 1 or 2. Well, since this is 1 or 2, this can never be 1, 2, 6 because that would eliminate all possibilities for that cell, so this can't be 6. So this is specifically 1, 3, 5, or it's 2, 3, 4. Either way, there's a 1 or 2 here. This is 1 or 2. So this can never be 1 or 2 anymore. And you can't have a 3 in it because one of these one of these 3 digits has to be a 3 because it's either 1, 3, 5 or 2, 3, 4. Can't be 1, 2, 6 anymore. So therefore this cannot be a 3, which means this can never be 6 because either it's actually no, it could be. It could be 1, 4, 6. Never mind. It's 1, 4, 6, 2, 3, 6, or 2, 4, 5. This can't be 3 either. So in this 9 cage, you always have 2 digits that are 1 through 3, and 1 digit that's 4 through 6, right? 1, 2, 6, which requires 1 and 2. 1, 3, 5, which requires 1 and 3, and 2, 3, 4, which requires 2 and 3. So the 4, 5, 6 has to be one of these two because it can't be 3 or 1 or 2. So the rest of the cage cannot contain 4, 5, or 6. It has to be a pair of 1 or 2. 1, 2, or 3. Okay. We no longer have the pinks that we have to worry about. So 7 has to be one of these 2 cells. We're not sure which. If this is 2, 4, 5, this would be 2. Okay, let's look at the possibilities. If this is 1, what are the possibilities here? If this is 1, it has to be with 4 and 6, right? This 1 means this has to be 2, 3, 4, so this can't be 4. So this would have to be 4, and that would be 6, if that's the case. If this is 2, 3, 6, this would have to be 2, this would be 3, and that would be 6. Because the 3 cannot be in this column either. If this is 2, 4, 5, this becomes 2, which forces this to be 1, 3, 5. Which would mean this could never be 5. So this would be 4, and this would be 5. So those are the possibilities for that. So if this is 1, this is 2, 3, 4, this is 6, and this is 5. If this is 2, 3, 6, this has to be 1 through 5, and this is 4. And if this is 2, 4, 5, this becomes 2, 4, and this is... Okay, so any of them could still work there. What can this... So one of these is blue. We're not sure which. One of these is orange. Seven cannot be any of these cells. That doesn't help us very much, though. We know 7 is either here or here, and 7 is either here or here. 7 cannot be here. Okay, we know this cannot be 1, 2, or 3. Because these two cells see it by normal Sudoku, this cell sees it by Knight's Move, and 1, 2, and 3 have to be there. So this cannot be 1, 2, or 3. So this is at least 4. That's 4 through 9, which means this is 2 through 7. Similarly here, this sees all 3 of the cells in the 6 cage. So this has to be 4 through 9, which makes this 2 through 7. Hmm. What are the remaining digits here? They have to be 3, 4, 5, 6 with 8 or 9 as possibilities. That doesn't really tell us much. Mm. Mm. Where is the blue in box 6? Can't be here because one of these is blue. Can't be here because none of those are 8 or 9. Can't be here because this is orange. Can't be here because of Knight's Move from the other blue. Therefore, there's only one spot left, which is here. So this is the blue 8 or 9, which forces the blue 8 or 9 to be one of these. And it cannot be this one because of Knight's Move from here. This doesn't limit anything there. Nor anything here. This can't be orange, 8 or 9 orange. But it still could be any of these 3. What else do we have? We know this can't be 5 or 6 because it sees this one from Knight's Move and it sees this from normal Sudoku. Can't be 7 either because, so therefore this is 1, 2, 3, 4, 8, or 9. We're not sure which though. This also can't be 5, 6, or 7. So this is 1, 2, 3, 4, 8, or 9. Okay. What else do we see? I'm not very good at seeing spotting Knight's Move stuff, so I will be very slow on this. What else do we know? All of these are 8 or 9. Sorry, one of these is the orange 8 or 9, and one of these is the blue 8 or 9. They all see the central cell here. So, these two from Knight's Move, and these two from Knight's Move, and these from normal Sudoku. So this can never be 8 or 9, because we know the blue one's here, one of these 3, which sees that one, and the orange one's one of those 3, which sees that one. So this has to be 1 through 7. Okay. What else does that mean? I'm not really sure. Hmm. Four cannot be either of these two cells and that one. Huh. So it cannot be these two because of normal Sudoku and Knight's move, and can't be that because of Knight's move. So this can no longer be 1, 4, and 6. Because if this is 1, 4, 6, the problem is if we try to make this 1, 4, and 6, that would break this for any possibilities because it can't have 1, 2, 6, can't have 1, 3, 5, and can't have 2, 3, 4. So that would not work. So this has to be a 2 then, which means this can't be 2. This cannot be 2, so this has to be 1, 3, and 5 specifically, which eliminates 1, 3, and 5 from the rest of the column. So this can't be 5. Therefore, one of these is a 2, because it's either 1, 2, 6, or it's 2, 3, 4, because it cannot be 2, 3, 5. So this is 2, which means this can't be 2. This can't be 2 anymore because of Knight's move. This is 1, 3, and 5. One of these is 2, so this cannot be 2, which means this can't be 9. This can't be 2 anymore. Hmm. So this is 2, 3, 6, or 2, 4, 4, 5. All of these are 1, 3, 5. The remaining digits in box 6 have to be 2, 4, 6, and 7. 2, 4, 6, 7. Well, this can't be 2, and this can't be 2 because of Knight's move from this 2. Therefore, this can't be 7. So now we have a 4, 6, 4, 6 pair in box 6, which eliminates 4 and 6 from the rest of the box. Therefore, this is a 2, 7 pair here. So this can't be 2, which means this has to be a 2. Because that's the only place that 2 can be now in this cage. And the 2 does have to be in this cage because it's with 4 or 6. Remaining digits now in column 7 are 1, 3, 5, and 7. And that's fine. This, I guess, will make red. This will make pink. So this is pink, which makes this red, which makes that red. So pink has to be one of these two. We don't know which, though. Hmm. Hmm. What else do we know? Not much. Remaining digits here are 1, 3, 4, 5, 6, but that's not really helping us much. Hmm. Hmm. Interesting. Okay. If this is 3 and 4, this has to be 5 and 6 here, as in the 11 cage. So this can never be 6 here, if that's the case. If this is 1, 6, obviously this can never be 6 also. So this can never be 6 here, specifically. This has to be 2, 4, 6, or 8. Um, this cage has to be either 1, 3, 6, or 1, 4, 5, or 2, 3, 5. This red one cannot be here. It can't be here. It can't be here, so it must be one of those two. Which means the red has to be one of those. Pink cannot be either of these, but it could be either of those. So unfortunately, we don't know where that is. Red is either here, here, or here. We don't know which. Could be any of these. It's one of those three, so it can't be that one, but it still could be either of those two and any of those three. Hmm. This can't be 7 because of this 7 from Knight's move, so this must be 1, which makes this 2, which makes that a 7. Therefore, 7 cannot be here. 7 has to be one of these two. So this can't be 7, which means this can't be 4. This can't be 2 anymore, so one of these is a 2. Which means this can't be 2. And one of these 3 has to be a 2, and specifically it can't be here. So one of these 2 is a 2. This sees both 4s and 6s, so it can't be 4 or 6. It also sees both 8 and 9, so it can't be 8 or 9. So it cannot be 1, 2, 7, can't be 4, 6, can't be 8 or 9, so this has to be 3 and 5. 3 or 5, sorry. Remaining digits here have to be 2, 3, 5, 6, or 7. But this can't be 7, this can't be 2. These could still be any of the other ones. Ah, but this sees also 4 and 6, so this can't be 6 either. Because it sees the pink one and it sees the red one. This is 3 or 5. 1 of 4, 6 is here. This cannot be either 8 and 9. Because it sees this one from normal Sudoku and this one from Knight's move. Can't be 1, 2, 7, so this is 3, 4, 5, and 6. But it cannot be the red one. Cannot be here either. It could be pink, or it could be that. But we're not sure which. Okay. I don't know if that's helpful, really, though. This green one cannot be here. Cannot be any of these. Could be here, here, or here. That's fine. Cannot be this one. Has to be one of these two, which forces it to be one of those three. That's not very helpful. Two is one of these two, which means neither of these can be a two, but we already knew that. Two has to be one of specifically these two cells, because it can't be here because of knight's move. And obviously it can't be here or here. Let's see. This cannot be 7, because if this is 7, it sees this one from normal Sudoku and this one from knight's move. So, therefore, this can't be a 7, which means where is the 7 in this column? It can only be here. So this is 7, which means this cannot be 7, this can't be 4, and this can't be 7. Okay. Um, what does that mean, though? I'm not sure. Yeah, I'm not very good at seeing knight's move, so that's why this is going so slow. So apologies for that. Oh, where can the 1 be in box 7? Can't be in any of the 11 cages, so it has to be one of these two. Well, what does that mean? That means these both see this cell, this one from normal Sudoku, this one's from knight's moves, and they both see that cell from normal Sudoku and knight's moves. So this can't be 1, this can't be 1. And they cannot be. So both of these also see this cell from knight's move. Both of them see it from knight's move, and this they see this cell from knight's move. So one cannot be here and one cannot be here. Well, where can the 1 be? Where can the 1 be in column 4? Can't be any of these cells because 1 is already in that box. Can't be here, and can't be any of these because we eliminated them because of the ones in box 7. So they have to be here. So therefore, this must be a 1, 2, 1, 2 pair here, which makes this a 3. So this can't be 3 anymore, or this is a 3, so this can't be 3. This can't be 3 here. This can no longer be 3. And that's all we kind of know. This, one of these has to be a 3 or 6. Well, we know this can no longer be 4, 7, so this is either 3, 8 or 5, 6. So one of these has to be a 3 or a 6. That eliminates 3 and 6 from the rest of the row, right? Because if this is 3, this can't be 6, but this would have to be 6. If this is not 3, this becomes 1, 6, which forces this to be 3, 8. So either way, this can never have a 3. So this can't be 3 here. What else do we know here? Do we know anything about this? Not particularly. This is a 1, 2, 1, 2 pair, which means 1 and 2 cannot be here. Remaining digits here cannot be 4, 8, and 9. So it has to be 1, 2, 3, 5, 6, and 7. Well, this can't be 7 because of knight's move. This can't be 7 because if that were 7, it sees that one from normal Sudoku and that one from knight's move. Do we have anything else, though? Not particularly that I can see. Hmm. What else? The rest of this row cannot contain a 3 or a 6 also. So this could be 1, no 2, 3, could be 4, 5, no 6, no 7, 8, or 9. So this is 1, 4, 5, 8, and 9 also. But obviously 1 can't be there. So this can't be 1. This could be 4, 7, 5, 6, 8, 3, or 9, 2. Okay, so those are the possibilities in this row. Hmm. What else do we know? We know one of these is a 4, right? Because we have a 4 here and a 4, 6, 4, 6 pair here, which eliminates 4 from the rest of those rows. So 4 has to be one of those 3, which means if 4 is one of those 3, they all see this cell by normal Sudoku or by knight's move. So this cannot be 4. So this is 1 or 5. Interesting. We know this is what. Okay, so this can never be 1, 4, 5 then. Right? Because that's the only way you can, and therefore can't have a 4. Because that's the only way you could have a 4 in a three cell 10 cage, right? You could have 1, 2, 7, 1, 3, 6, 1, 4, 5, or 2, 3, 5. But 4 requires having a 1, 4, 5 here. So this cannot be 1, 4, 5. It then has to be 1, 3, 6, or 2, 3, 5. Either way, there's a 3 here, which means this cannot be 3, and this can't be 3. Right? It's either we've eliminated 1, 2, 7. 1, 4, 5 just got eliminated because this can't be 4. And therefore, this must be 1, 3, 6 or 2, 3, 5. In either case, we have to have a 5 or 6 in one of these, which means this cannot be a 5, 6 pair because that would eliminate all possibilities for this cage. And this can't be 3 and 8 because we've eliminated one of these has to be a 3, which means that can't be 3, 8. So either this is 1, 3, 6, or this is 2, 3, 5. So 1 or 5 has to be in this cage. This has to be 1 or 5, which means 1 or 5 cannot be in the rest of the column. So this cannot be 1, 5. This can't be 3. What does that mean? If this is 1, this obviously becomes 5. This is 1, 6, then this becomes 5. This is 3, 8. So then the remaining digits would be 4, 9, and 4, 9, right? However, if this is not 1, this would have to be 3 and 4, which would force this to be 5, 6, which would make that 1. So if this is 3, this is 5, 6, 5, 6, this is 1, this is 4. Okay, so what are the remaining digits here, I guess, is the question. If this is 1, 6, this is 5, this is 3, 8, this has to be 4, 9, and 4, 9. If this is 3 and 4, that forces this to be 5, 6. That's 1 here. So then this would have to be 8, 9, and 8, 9. Interesting. So we know this can never be 6 then. This has to be 2, 9, 3, 8, or 4, 7 here. Can we have something similar here is the question. 1 or 5 cannot be here. 3 cannot be here. So no 3 or 5. It could be still 2, 9 here. This could be 8 and 3, and this would be 4 or 7 as a possibility. This could be 6, and that one could be 5. Okay. Interesting. We don't have anything between 2, 4, and 7 here, do we? Not particularly. Well, okay, if this is 1, 3, 6, that means this is 5. This is 2 or 7. This would have to be then 2 or 7, which would eliminate 2 or 7 from being a possibility there. But that's all it gives us. Well, that does tell us this can never be 2, right? Because the other possibility for this cage is 2, 3, 5, right? And then this would be 1. This would be 4, 7. Ah, hold up. Yeah, this can never be 6 either, right? Right, so if this is 1, okay, so say this is 1, 3, 6. If this is 1, 3, 6, what did the rest become? If this is 1, 3, 6, this becomes 5. This is 2 or 7. This has to be 2, 4. If this is 2, this has to be 4, 7. If this is 7, this is 2, 9. So what would that leave as the other possibilities? Again, 1, 3, 6, 5. I guess you would have 4 and 9 as possibilities here. Or 8, right? Right, because you can't have 2 and 7 because that's 2 or 7. You can't have 1, 3, 6, or 5. So it'd be 4, 8, and 9 as the possibilities here then. But this can't be 4, interestingly enough. So this would be 8 or 9. This would be 4, 8, or 9. Now, what are the other possibilities you could have? If it's 2, 3, 5, this becomes 1. This is 4, 7. So this becomes 6. And then you require this to be 8, 9, and 8, 9. So, no matter what, this is an 8 or 9. So this has to be the blue one. Which means this blue one sees all of these. So it can't be here. It can't be here. It can't be here. Well, we already knew that from that 8 and 9. Can't be here. It can't be here. This is 4, 8, or 9. So the possibilities here are 2, 3, and 2, 3, and 7. Which means this cannot be blue either. So this can't be blue. None of these can be blue. This can't be blue. So blue cannot be here. So blue has to be one of these two. Interesting. Orange cannot be here. Orange could be here. So orange could be any of these 4. That's pretty broad still. Hmm. Hmm. What does that tell us? Not much. But at least that gives us... Actually, it clarifies a certain amount. This has to be 1, 2, 1, 2, 3, or 5 in the remaining row. This is 1, 2, 3, or 5. This can't be 3 because of that 3. Hmm. Hmm. That means this can never be red, but doesn't tell us much. Hmm. This is interesting. This is either 1 out of 4 or 7. Well... Yeah, this is either 1 out of 4 or 7, or it's 2. If this is the 1 out of 4 or 7, this has to be 2, 9, or this is 2, 9. Because neither of them could be 5 or 6. Because if this is 5, 6, this becomes 3, 8, and this is 1, which eliminates all possibilities for that cage. Same here, right? So, if this is 2, obviously none of the rest of the box can be 2. If this is 1 out of 4 or 7, this becomes 2, 9, or 3, 8, and this is 2, 9, or 3, 8, which would mean none of the rest of the box could be 2, right? Because you can't have if this is 4, 7, that eliminates 4, 7 from being either of these cages, which forces this to be 2, 9, 3, and 8. So this can never be 2. It's 4, 6, or 8. This, however, could be 4, because then this could be 7, and then 2, 9, 2, 9. This could be 6. Yeah, that's fine. Hmm. Can this ever be 7? Possibly, right? Hmm. Hmm. Yeah, I'm sorry, guys. I'm so slow at this because I'm not good with Knight's moves. But I wanted to do this anyways, just to, see what's going on. Um, oh, interesting. Okay. This is red. So therefore, none of these could be red in this box. Red can't be any of these in this box either. Where is the red in column 6? It has to be one of these two cells, but we don't know which. I don't know if that tells us very much, but that's actually a very interesting piece of information. Red cannot be here, but red could be one of these two. Or any of these three. Hmm. Oh. Blue cannot be any of these cells or any of these cells. Blue has to be one of those two. So this can't be blue, so blue has to be one of those two. That doesn't really tell us much there either, but it does give us some information. Um, hmm. One thing we do know is if this is 3 and 6, that makes this a 5, which means the rest of the row cannot be 5. If this is 4, 5, obviously the rest of the row cannot be 5. So the rest of the row cannot contain a 5 here. I don't know if that tells us anything, but, maybe that's something. If this is 3, 6, then this becomes 5, which makes this 2, 3, 5. Hmm. Hmm. Oh, that's interesting. If this is 2, 4, 5, what does that make this? Well, we need a 3 in one of these two cells, or one of these three cells. So this must be 3. But then where's the 6? The 6 has to be outside, right? because we don't have a 6 in the row already, because this is 2, 4, 5. So if this is 2, 4, 5, this obviously has to be the 3, because the 3 has to be in this cage. And there's no 6 in the rest of the row, so the 6 has to be outside, which forces this to be 2, 3, 5 then. But if this is 2, 3, 6, that forces this to be 5, which then again forces this to be 2, 3, 5. So either way, this is 2, 3, and 5. So it cannot have 1, it cannot have 6, it has to have a 2. So this is a 2, which means this can't be 2. This is 2, 3, and 5, which means this can't be 2. So this is a 4, 7 pair, which eliminates 2 and 7 from the rest of the column. So this cannot be 7 or 2. This is 6. This 3, 5 forces this not to be 3 or 5. So this is a 1. And now we have an 8, 9, 8, 9 pair. Well, this has to be blue. Therefore, this must be orange. So none of these can be orange. This is orange, which means this can't be orange. So this is blue, which makes that not blue. So that's orange. Well, blue can't be any of these anymore. So therefore, this can't be blue and this can't be blue, which forces this to be the blue. So this has to be, we have a 2, 9, 3, 8 quadruple in box 7, which eliminates 2, 9, and 3, 8 from the rest of the box. So this can't be 3, this can't be 8, this can't be 1, this is 3, which makes that 4. This can't be 4. This has to be the orange 8 and 9. And this can no longer be the blue 8 and 9, therefore this must be the blue 8 and 9. So we have all the blue 8 and 9s, except for we don't know what this one is. We have a decent amount of orange, so the orange 8 and 9 has to be the remaining one of these two digits. Because we know this is the 8 and 9. This is not 4, so the pink has to be 6. The red, though, is a 4. So the red is a 4, so it cannot be that one. The pink is a 6, so this is 4, which makes this a 6, which makes this 3. So the green is a 3, which means this is the green here. Pink is one of these two. We're not sure which. This cannot be 3 anymore. This can't be 3. This can't be 3. This can't be 6. This can't be 6. This can't be 3. So this is 5. This can't be the red then. This has to be 3. This can't be 4. Okay. This can't be 6, so this must be 5, which makes that a 6. This can't be 5 anymore. 3 can't be here, so this must be 1, which means this can't be 1, so this is 5, which makes this a 3. So this is the green. Oops. This is 5. This can't be 1, 5, or 6. This can't be 1, 5, or 6. Well, we have a 2, 3, 2, 3 pair now in row 4, which eliminates 2 and 3 from the rest of the row. So this is 7, this is 2. This can't be 2, so this must be 1, which makes that a 2. These can't be 2, and it can't be 3 either. So we have a 1, 5 pair. This can't be 2. This is 4, 7, 8, or 9. We're not sure which. This is 1, 5, or 1, 5 here. This is 4 with 8 or 9. This can't be 5 anymore because of this 5, so this must be a 6, which makes this a 5. This cannot be 1, so this is either 4, 6, or 7, because those are the only digits remaining. 6 cannot be here because of this 6. Let's remove the reds, and because that's not helpful. Okay, this is a 4. This is a 6. The pinks aren't helpful either. The greens are no longer useful either. What does that tell us? I'm not really sure. The 7 has to be one of these two cells. That's what it tells us. So this can't be 7. Therefore, oops, this cannot be 7. Therefore, this must be the 7. This is 1 or 5. This is 1, 5, or 6. This is 1, 5, or 6. Um, hmm. If this is 7, that forces this to be 7. If this is 7, that forces this to be 7. Well, either way, that works. This cannot be 1. Yeah, let's look at the remaining digits. So we have 1, 3, 4, 5, and that's it. 1, 3, 4, 5, right? This can't be 3. This can't be 3. This can't be 1 or 5. But it could be 3 or 4, though. And this is 3, 4, 8, and 9. This is 3, 4, 8, and 9. But this sees a 3 here, and this sees a 4 here. So this has to be 8 or 9, which means this cannot be orange. So this is not 8 or 9. This is 3 or 4. Orange is here. Blue is here. Orange cannot be any of these. So this still could be either. So orange is either here or it's here. Cannot be here because that forces this to be not 8 and 9. This has to be 3, 4, 5, and 6. It cannot be 3 because of knight's move here. What does that tell us? I'm not sure. As I told you before, I'm not good at knight's moves, at seeing them at all. It's really hard for me to see them for some reason. One of these, okay, so this is 5, which means neither of these can be 5. Okay, there we go. So now we have a 1, 4, 1, 4 pair in column 5, which eliminates 1 and 4 from the rest of the column, so this can't be 4. Therefore, now we have a 5, 6, 5, 6 pair in box 2, which eliminates 5 and 6 from the rest of the box. This can't be 5 anymore, which makes this a 3, which makes that 4. This 4 means this can't be 4, so this is 3. This 3 means this can't be 3, so this is 2, and this must be 9, which makes this 8 and 3. So all the blues, well, we can remove, let's remove these. All the blues are 8, and all the yellows, or sorry, not yellow, oranges are 9. Well, let's remove that coloring too. So these must be 9. These can't be 3 anymore. This can't be 2, so this must be 5, which makes that a 2. This 5 means that can't be 5, so this is a 1. This can't be 1 or 5, so this must be 6, which makes that a 5. Which makes that 1, which makes that 5. This 5 means this can't be 5, so this is 6, which makes that a 5. This 1 means this can't be 1, so this is 4, which makes that a 1. This 6 means this can't be 6, so this is 4. That makes that 7, which makes that 4. That makes that a 6. This has to be a 7, because that's the only other place for it. And this has to be a 9. Okay. So this can no longer be 8. The remaining, this can't be a 7. This can't be a 2, so this is a 3, which makes that a 2. This has to be 7. This can't be 5 because of that 5, so this is a 1, which makes that 5. This can't be a 4, so this must be a 9, which makes this an 8, which makes that a 9. That makes that 4, which makes that an 8. And now that we're just doing normal Sudoku, this is a 1, and this has to be a 6. Yeah, it's pretty straightforward, but straightforward for a knight's move, Sudoku, which I, again, am not good at. I've tried improving it. For some reason, I just don't see things. And I mean, notice it took me that long to figure out this 5 forces this not to be a 5. But anyways, other than the slowness, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.